Good afternoon, everyone. My name is Ben Berry. I'm a senior developer at CrossComm. We're a mobile, web, VR, AR development shop out of Durham. We've been around for 20 years now. We do various kinds of apps, whatever people need done. So we've built a couple of Bluetooth apps where we have a couple developers that full-time spend their time working on augmented reality and virtual reality applications. But that's not my specialty. I tend to work on the Android and the server backends of the projects that we work on. And when the opportunity came up to give a talk at RIoT, I thought it'd be good to sort of share some of the things that I've learned that I sort of had to stumble my way through the first time I was trying to get up and running with a BLE application on Android, which actually turns out to be fairly straightforward once you understand some of the jargon, some of the Bluetooth way of thinking about certain things. And so given that RIoT did provide such a generous time slot, I actually thought it would be good to just start with sort of an overview of Bluetooth, and I think this is helpful in sort of thinking like a Bluetooth developer and sort of understanding where it came from. And the primary things to know when you think about Bluetooth is sort of where it fits in the niche. So it's shorter range than Wi-Fi, it's longer range than NFC. And classic Bluetooth, or Bluetooth Classic, or just Bluetooth, if it doesn't have a modifier, if it's not low energy Bluetooth, then one of the characteristics is that it's always, thank you, that it is always transmitting. And that has its upsides, that has its downsides. The main downside obviously being power consumption, which is where eventually Bluetooth low energy came along. But when I actually started digging into it, Bluetooth LE didn't actually come in until version 4.0 of the spec. And Bluetooth 1.0 actually came out in 1999, which, when you think about the fact that the first iPhone came out in 2007, that's actually pretty far ahead of the curve, I thought. I don't know what they were quite thinking at the time, and the first 1.0 spec was actually borderline unusable. Basically, the different manufacturers couldn't actually agree, and so people would produce devices that couldn't connect to anything else, and everything. Part of the problem with that is throughout the Bluetooth ecosystem is everything is supposed to be low cost. And you have complex spec, low cost, you get issues. So Bluetooth 1.2 came along in 2003, took them a couple years to get it right, and that's when we started seeing these things, which was basically all that you could really do with Bluetooth at the time, just because it primarily was useful as a short-range voice transmission protocol that was low enough that could send a voice signal that didn't sound bad over the phone. So Bluetooth 1.2 was pretty low bandwidth, pretty low bit rate as an audio signal, but when you're sending it over a telephone anyway, nobody really cared. But nobody was making Bluetooth earphones because it would sound like you were listening, to your computer over a telephone link. So nobody wanted that. They started revising the spec. There was Bluetooth 2.0, Bluetooth 3.0 in 2009, which had, there's a version of Bluetooth called Bluetooth AMP, which is also known as Bluetooth High Speed, which actually uses 802.11 Wi-Fi. Even though it's Bluetooth, it's very confusing and nobody really implemented it, which gets us to Bluetooth 4.0 in 2010, which is when they brought out Bluetooth Low Energy and everybody was like, yeah, that's the winner. Let's do this now. And so the main thing that they changed with BLE was switching from that always transmitting model to a model where you only transmitted when you had data to send. And so obviously if you have something like a Fitbit or some kind of Bluetooth beacon, you don't have to have some kind of complex, power costly handshaking process to establish a bond. You send the data that you need to send, and then you break the connection. So in Bluetooth, there's no idea of pairing. You just connect to the device, you scan, you see what's there, you connect, you send data back and forth, you disconnect. Bluetooth, from the beginning, always had this concept of pairing, which part of what was entailed with that was the idea of security. You would pair one time up front, and then you actually exchange a set of cryptographic keys, and so all traffic after that between the two paired entities is encrypted. You don't get that in Bluetooth Low Energy, but you don't always need it. If all you're doing is reading a beacon in a store or trying to go to a URL by tapping your phone on it or something, you don't need encryption. It's public information. After that, there have been a number of revisions to the spec. 4.0 is really the main one. That's when Bluetooth Low Energy was added. There's been 4.1, 4.2, 5.0, 5.1, and we were talking a little bit earlier about what's actually in these specs, how widely are they supported, and the answer, as with anything in Bluetooth, is it depends. And the more time goes on, the more widely any given thing will be supported. But we're just now really getting to the point where most devices have really robust Bluetooth Low Energy support. You might also ask, how does this relate to all these Bluetooth earphones with these audio codecs? Like, does Bluetooth 5.1 mean that it supports the aptX audio codec? And the answer is no. No, that's completely separate. So some devices, you can have a 4.0 device that supports a high-def codec, or you could have a 5.1 device that doesn't support any high-def audio. So I wish it were simpler. It's not. It's a mess. But most of this stuff is tangential for us because BLE, as far as it goes, is BLE. If it supports Bluetooth Low Energy, it supports the 4.0 spec, that's what we actually care about. As far as the context around Bluetooth, again, just trying to sort of give you a little bit of let's call it cultural fluency. So when you run into these Bluetooth terms, understanding what they mean. I just wanted to run through a couple of the profiles that make up Bluetooth, that the Bluetooth spec defines. I think I've got 7 here. The actual spec includes 30 or 40, but these are the 7. If you run into any, these 7 will probably be most of them. And the profiles, you can think of them as sort of the protocols that run on the Bluetooth connection. So if Bluetooth is TCP/IP, these are HTTP, FTP, SCP, these kinds of things. So the most basic one is GAP, Generic Access Profile, which is just how Bluetooth devices advertise themselves and handshake and establish connections. So if it supports Bluetooth at all, it supports GAP, because you can't do anything else without GAP. It's, again, to use a network analogy, it's kind of like ARP almost. The next sort of most common, depending on how you look at it, Bluetooth profile would be A2DP, the Advanced Audio Distribution Profile. It's been called advanced since like version 1.6 of the spec, so it's basically just the audio protocol. But the thing to know when you hear A2DP is one-way audio. So when you're listening to music through some earbuds and it's only going from your phone to your earbuds, that's A2DP. It's relatively high fidelity one-way audio. So for example, these things, my little Bluetooth earbuds that we'll actually come back to later, when I'm listening to music, they're transmitting over A2DP. If I hit the little controls here, the pause, the stop, the continue, that is a separate profile called AVRCP, which is the Audio Video Remote Control Protocol, which basically just allows you to send pause, play, start, stop, skip events. Because that's not technically audio data, it's sent on a separate channel, essentially. So it's a separate protocol. What the Bluetooth earbuds and the two-way audio protocols use is what's called HSP, headset protocol, which this device, it has a microphone in it. So when somebody calls me and it switches over from listening to my crystal clear music to hearing them go womp, 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 over a telephone line, it's actually switching from A2DP to HSP. The audio is being sent over a different protocol. Because what HSP does is instead of using all the bandwidth of the Bluetooth connection to send the high quality audio one direction, it splits it in half and sends half the traffic either way. So you're cutting your bandwidth in half to be able to have a two-way connection. And that's what phone calls use. If you're using Bluetooth headphones connected to your computer, to talk on Zoom or Slack or whatever, that's HSP. The PBA, this is often implemented, not often used, but this is phone book access. This is just how the Bluetooth device can say, for a given phone number, if a phone call is coming in, do you have a contact in your phone book that has a name for this? So that when your phone or when your car stereo is trying to say, hey, so-and-so is calling you, do you want to pick up? The stereo can display their name from your phone's phone book instead of just saying their phone number. And then the last common Bluetooth classic profile is just the HID profile, which is a thin wrapper around the USB HID protocol, the Human Interface Device Protocol, which is how you send keyboard events, mouse events, so you can send key presses, modifier plus a key press, your standard USB HID mouse and keyboard type actions. And so that's how, if you have a Bluetooth keyboard, it's sending that, and so it's just a thin wrapper around the USB HID protocol. So those are the main not USB, the main Bluetooth Classic protocols and profiles. The one other one that's on this slide that is used but not as a part of Classic Bluetooth is GATT, which is just the generic attribute profile. The T's don't stand for anything, it's just generic attribute. But this is what Bluetooth uses to send data back and forth, because it's not sending audio data, it's just sending attributes. So that's their sort of generic term for it. So just as a sort of illustration of this, I thought it would be interesting. So this is actually, when I connected these Bluetooth earbuds, this is what my phone shows me. And so we've got the phone call selection, so phone calls, that's using HSP. We've got media audio, that's using A2DP. We've got HD audio, which that's not any of these profiles. Like I was saying, all the HD audio codecs are a completely separate part of the spec. And then we've got contact sharing, which apparently I've disabled because I think my earbuds are spying on me, apparently. But that would be using PBA, phone book access. So these are sort of, when you go and you look at your earbuds and you're like, why does it give me this granular control? This is why, is they are actually each separate protocols that the Bluetooth, or separate profiles that the Bluetooth protocol enables. And if you can switch them on and off, Android says, why not show that to the user, let them choose if they want to. But most of the time, you're just going to leave them all on. Any questions about this stuff before we start getting into the, yeah?
Is the address the part of the GATT when you're doing discovery?
So that would just,
the NIC, right?
Yeah, that's just the MAC address.
I mean, how's it sent over? Is it sent through one of those profiles?
So the MAC address would actually be at sort of a lower level of abstraction than Bluetooth. It would be, so that's sent just by the radio, and maybe it's sent over GAP. That's actually a good question. But so a Bluetooth device will have the same MAC address whether it's BLE or Bluetooth Classic. If it were sent over Bluetooth, it would be over GAP, not GATT. Okay. So probably. Yeah. So there's the MAC address on my phone, or my earbuds, if that's interesting to anybody. So when we get to Bluetooth data, the way that the data is organized is hierarchical in this fashion. You have the GATT profile, which is sort of the envelope that holds everything, and then within the profile you have what the Bluetooth spec calls services. And if you read services and you think Unix daemons, or you think a web service or anything like that, that's not at all what they are. Services are just groups of characteristics. So it's just a grouping. There's no idea of connecting to a service. It's just like a folder that holds some files. The actual magic happens with characteristics, and the characteristic is sort of the smallest unit of work of a Bluetooth connection. So you have a characteristic that has an ID, that is a member of a service that has an ID, and you can read and write the value of that characteristic, depending on if the device supports it. So there may be some characteristics that are read-only, as you might expect. But assuming it's a read and write characteristic, you can read it, you can write it. And then the characteristic will also have some read-only descriptors. So for example, you could have a Bluetooth thermometer, and it might have a characteristic that is the current temperature, and then a descriptor that tells you whether it's Celsius or Fahrenheit. And so because those two data points are linked and sort of only make sense in the context of each other, they are a part of the same characteristic. So the value tied to the descriptor gives, the descriptors give the value its usefulness, so to speak. So you can have multiple services. Each service can have multiple characteristics. I think everything depends on the implementation, but the most common numbers are something like a device can have 10 services, and each service can have 10 characteristics, something like that. In practice, you can get by with having a lot of data written and read from the same characteristic. If you're writing a device that wants to be interoperable, it's better if you follow some known IDs. So there are sort of the Bluetooth spec lays out certain UUIDs that say, oh, this is a thermometer, or this is a heart rate monitor, or this is a Bluetooth speaker. And so if you want to be sort of generally interoperable, then you would want to follow those and advertise and respond on those services. If you are making your own device, then you would come up with your own UUID, register it with the Bluetooth SIG that deconflicts these sorts of things, and then that's your ID, and your application can use whatever service and characteristic IDs that you want them to. The interesting questions, again, this gets back to the difference between what's in the spec and what low-cost device manufacturers actually implement. How big, how much data can you hold in a value and in a descriptor? The spec says 512 bytes, but a lot of low-end devices won't necessarily support that. By default, when you're actually transmitting data, so a given by the spec default of an MTU, a maximum transmission unit, is 20 bytes at a time. And so most people say just only store an MTU's worth. So that might be 20 bytes. We've used some Bluetooth devices that'll negotiate up to a 40 byte MTU. But if you really want interoperability, I wouldn't store much more than that. Now, if you control both ends of the connection and you've got a Bluetooth chip on your thing that you've tested and you can write 512 bytes to a descriptor, have at. But in terms of interoperability, the thing with Bluetooth to always be remembering is lowest common denominator. You could be trying to interact with something that costs $10 from, the gas station. You never know. I got a question when I gave this presentation before. What happens if you exceed the MTU? Undefined behavior. So, like, I've had devices that just stop responding, and you have to pull the power and reboot them. Some just reject it, some truncate it. So this is the problem. The spec doesn't say, and so you can't really guarantee it. And so just be careful and don't. Whatever you negotiate with the other endpoint, whatever you negotiate the MTU to be, stick to that. What can you do with a characteristic? You can read and write them, assuming they allow them. And then the real magic of BLE is that you can subscribe to a notification. So rather than in a traditional Bluetooth model where you are transmitting constantly and receiving data from the other end constantly, in BLE, if there's no data to send, you don't send any data. So the question then becomes, how do you tell the other end that you want to be notified when something changes? Well, BLE actually includes the idea of registering for a notification. So you can signal to the other device and say, when this characteristic changes, notify me. And so that device then remembers whatever your MAC address is in its table of people to be notified, and when it sees that it's modifying that characteristic, it reaches out to you. And so it switches the paradigm from a polling model to a push model, which has obvious power advantages. Anything on this slide any questions before we move on?
Can you negotiate the MTU on connection, or is that just set?
No, so by the spec, it starts at 20, but then you can negotiate with the device. You can basically say, hey, I want this MTU, and it'll come back to you and say, here's what I can do for you. So I think later on some of the sample code, I've got a line where it's requesting an MTU of 256, which is effectively infinity, and it's just whatever the biggest value the device will give me is what I'm going to get back. But yeah, and you can change it after the connection if you can inspect some characteristics and say, oh, I recognize what this is. This thing is from manufacturer ID such and such. Let's negotiate a higher MTU. Or if you see a low power device, you can negotiate lower. But it's something that can sort of be a part of the ongoing connection. All right. So the rough outline of the steps that we're going to go through in this app. So the first part is that we're going to scan for the devices with a filter. And part of this is just because there are so many BLE devices at any given time that if you scan without a filter, you'll just get results out the wazoo. So just for fun. So if I just standing in this room, and I try and scan for BLE devices. So I can see a couple Fitbits, I can see a Smart Bee, and 35 other devices that don't even advertise like a connection name. So it's just beacon. They could be beacons. They could be things that aren't in any kind of pairing mode. So literally just standing in this room, I can see 40 BLE devices, and so scanning without a filter really is not particularly productive. So you specify what it is you want to find, whether it's a manufacturer ID. You can scan for anything that supports a particular service. So if you're looking for a heart rate monitor, you can just say scan for anything that supports the heart rate monitor protocol, or not protocol, service, heart rate monitor service. You connect to the device. You don't have to go through any pairing. The device at the other end doesn't have to approve. It's not like Bluetooth where they have to click OK or enter a code or anything. If you are advertising as a BLE device, then anybody can connect to you at any time for any reason. In the software, we will get what's called a GATT client. That's Android's software abstraction term for what we use to interact with the GATT protocol. But again, don't be fooled and think that, oh, client is paired to server or service. Nothing like that. It's basically just a software handle to send and receive data from a BLE device. We'll discover what services are available on this device. So we will run a command, and then it'll tell us, hey, this device supports heart rate monitor and temperature and clock, and whatever the thing supports, it can report that back. And then we'll start getting characteristics, read values, read descriptors, write the values, and then subscribe to notifications if we want to know when a characteristic changes. So that's the end of the slides. Here's the beginning of the code. I hope you're ready. So when we're actually scanning for the device, we will, in Android, the class that we use to do this is called Bluetooth adapter. And we'll just get the default adapter. Most Android devices only have a single Bluetooth adapter. You may want to enumerate the list of adapters if you want to really be belt and suspenders, but if you just want to trust the user, whatever the default adapter is, you can just get that. If it's not enabled, you can invoke an Android system class to basically pop up something and ask the user to enable it. But we're just going to, in this event, we're just going to throw an error if it's not. And then we will use a library that I find quite handy on Android. So for anybody doing Android development, this is this context.runWithPermissions. This is actually not a system class. This is a utility library called runWithPermissions that only works in Kotlin, I believe. But it makes life significantly easier. You basically, instead of having to request a permission and wait to be told that you either have it or don't have it and then run the code, you just wrap the code that you want to run in this block and say, either get the permission, or if I already have it, just run the code. So I'm cheating a little bit by using a utility library, but it's something that I highly recommend. And so if you're using Android, I would say just switch to this. It makes your life easier handling all these events with getting runtime permissions, since we've had to switch to that in the last couple of years. So the code that we'll run, well, actually, let's talk about the permission. Access course location. Why do we have to have access course location? So because there are so many BLE beacons out in the world, and so many beacons have been mapped to particularly physical locations, an app can, with a fair degree of certainty, figure out where you are just by scanning what BLE devices are around you. In the same way that if you turn off the GPS on your phone, Google can figure out more or less where you are just by which Wi-Fi networks you can see. It's roughly the same idea. And so in order to be able to scan for the BLE devices around you, the user has to agree to give you the location permission, which is definitely a little bit confusing. Every time, this is some sample code. Anytime we actually do this in production, we pass an object to the run with permissions that lets us basically set up a rationale to say, hey, here's why we need the location permission, so that if the user denies it, we can say, like, no, we actually do need it for Bluetooth. Here's why. Because it's a little counterintuitive, but when you actually think about what you can do with BLE scanning, you need it. Now, if you don't need to scan, if somehow you know the MAC address of the BLE device you want to connect to, then you don't need this. But if you want to do a scan can be translated into course location, and so you need the permission. So just like anything in Android, you add a couple things to the manifest. Access course location is one of them. Bluetooth obviously is another one, and then Bluetooth admin is the permission that you need to make connections. So if all you had was the Bluetooth permission, you could use existing connections if somebody had already set them up, but to actually initiate a new BLE connection, you need Bluetooth admin. Yeah?
Does Android have the concept of a parent process, and can you inherit permissions from a parent process so that you could basically congregate or have apps developed with greater permission or
Not really. Sort of the app is the smallest unit of work within sort of Android, and so either your whole app has been granted location permission or none of it. But you can have, if you were to have this in some kind of shared code library that was used among three, then any time that code was invoked, the code would run in the context of that application, and so it's whether that application had been granted location that matters. So then we modify that a little bit so that we actually scan with filters, which just involves creating a couple of objects. The first one here is we're just taking the UUID of the service that we want to scan for as a parameter into this function. So that's the second function, or the second parameter. These middle three lines, we wrap that in a parcelable UUID. We hand it to a scan filter builder, and then we wrap that in a list, and we get a list of filters where the filter just says, look for anybody that supports this service. Because if we want to specify filters, we also specify settings. We create a settings object here that is, we're just basically saying make it a low latency scan, so by definition high power. And then we pass that into the second parameter, but this start scan method is exactly the same as what we just used. It's just we're giving it 3 parameters instead of 1 now. So this is the scanning process sort of in one slide. So what we passed here, this callback parameter, is an object, and that object looks something like this. So again, this is Kotlin, but we're just defining an anonymous object that implements the scan callback abstract class. Scan callback lets you respond to a number of events. The ones that we care about here are batch scan result and on scan result, which it just depends on how the device delivers the result. We're going to do the same thing with either of them, which is pass it to this little device found helper function, which all that it does is once we find the device, we connect to it. In this scenario, we're assuming that if it implements the service that we're looking for, we're just going to immediately connect. If you wanted to do some further inspection on the device before you connect to it, you certainly could. You would want to do that in something like this device found function. You would say, oh, you support the heart rate monitor protocol, or heart rate monitor service, but are you manufactured by Fitbit? Like if you only wanted to manufacture, but then you would just scan for Fitbits in the first place, but you get the idea. So this callback is just our way of acting on the results that are delivered to us by the scanner. There's another function that we can implement here called onScanFailed, which would just be, if for whatever reason we weren't able to scan, then you can show the user your error message or abort or whatever it is that you need to do. You can register for that on the callback. So that's sort of the outer callback. This is the actual connection callback or the scan callback, you could think of it as. If you, in that device.connect GATT, which, like we talked about before, so GATT is basically BLE in this context. If you go looking at the docs trying to find, like, where's the connect BLE method? It's not there. It's connect GATT. When you call that, you give it the context. You give it this middle parameter that just says, do you want to wait around if the device isn't currently available and connect later? And then you give it GATT callback, which is just like this is a scan callback. GATT callback is another class that you can implement. And I know that this is quite a lot of text, but we'll be on this slide for a little while, so we'll work through it. So just like the last one, this is an anonymous object. It just implements the Bluetooth GATT callback example, abstract class. The first thing that you're going to do in your GATT callback is you want to implement this onConnection state changed method, which just tells you when you connect or disconnect to something. So in this example, all that we're doing is looking to see, oh, is the new state, so you're given a status, which is the old state, and you're given a new state integer, which is just a member of an enum. You look that up and you say, oh, is the new state connected? Okay, well then, in this case, we're negotiating a higher MTU, and then we're kicking off the job of discovering the services. So before we can actually start connecting to any of the services, we kick off the discovery of them. Everything in this callback, just like the last one, is going to be asynchronous. So you kick off the scan, and then your scan callback gets invoked. You kick off the Bluetooth GATT connect, and then when the connection completes, you get the state change, and then you kick off discover services, and again, you go to sleep until the services are discovered, and that's when you get the second callback method. The parameters to this, so the GATT that's just a parameter that basically is the class that is your interface to and from the device. So again, you're speaking in generic attribute profile to and from the device. The idea is you're not actually holding on to that reference yourself. It's just any time that your callback is getting called, it gives you a handle to the device. You can make whatever manipulations you need and then let it be freed when your application or when your function goes out of scope. You have a status in case you just want to make sure you're connected. And then from the GATT, so this first line under on services discovered. Again, sorry that this is a little bit cramped, but that's where you actually can get a characteristic. And so you use this GATT interface. You say, give me the service with this UUID. In this case, we're going to get the battery service, and we're going to get the characteristic within that service for battery life. And so that just returns an object in Android that is a Bluetooth characteristic. Now, you can think of this as sort of a shallow copy of or a reference to the characteristic on the device, but it isn't actually, it doesn't necessarily have up-to-date data. So for example, if you want to read the value of that characteristic, you won't actually get it on that first line. So when you call get service, get characteristic, you could actually, from the variable returned by that, you could call get value and it will be null because you haven't actually read the value of that characteristic. You just know that it exists. You just have a reference to it. If you do, well, so this again, this code has been slightly compacted to fit on this slide. You wouldn't actually want to call all of these operations back to back because each one of these is going to kick off an asynchronous operation. So for example, when you call GATT read characteristic, you are actually going to then wait until your GATT callback gets on characteristic read. That's when you're actually going to get your data back. So you kick off the read, and then when the data comes back, your on characteristic read is invoked. It tells you, here's the GATT that we read it from, here's the characteristic that we were reading, and a status flag that is just, are you connected still, all that. You can kick off that read. You can subscribe to a notification. So that's what this sort of middle line, this set characteristic notification line. Again, once you get the characteristic, you tell the GATT, hey, tell the device to let me know when this changes. And true is just a Boolean parameter. If you wanted to disable notifications, you would set that to false if for whatever reason you decided you knew what you needed to know from that characteristic. If you wanted to actually write to the characteristic, like I said, you can write to a value parameter of the Android class that you have, but that won't actually write the data. Now, obviously here, we're not going to write to a battery life. That doesn't make any sense. This is just some sample code. But if you wanted to tell a device what its battery life was, you would assign the value of the characteristic, and then you would say to the GATT, write this characteristic. And so it'll look at the ID that belongs to the characteristic and the value that you've set on it. And then for any of those operations, when they complete, you will get a callback invoked. For example, one of the things that is very much best practice is anytime that you write to the device, you should register the on-characteristic write callback, and then just make sure that the data, the value that comes back from the write is the data that you sent. Just to be on the safe side. If the device decides that that characteristic is read-only, then when you get the data back, it'll say the characteristic's value is what it used to be. It's not what you wanted to write to it. If for whatever reason you try and write 30 bytes to it, and that particular device only allows 20 bytes in a characteristic, then what you'll get back is a value that's only 20 bytes. And so you sort of have to implement your own verification by answering to that onCharacteristic write function, just to make sure that what you wrote actually got written to the device. And then if you've subscribed to the notifications, that's when this onCharacteristic changed will get called. It's just the one function that gets called for any characteristic. If you have subscribed to multiple, obviously you'll want to look and say, oh, this is the heart rate, or this is the temperature characteristic, and then act accordingly. But in this scenario, in any of these callbacks, the characteristic as it's passed to you will actually have the current value of the characteristic. So in a read, a write, or a changed, you can trust, as we are in the bottom line here, you can just take the value off that characteristic and log it or do whatever you want. So this is really where all the magic happens, so to speak. It's this loop. It's making the connection, discovering the services, setting up what you want to subscribe to, saying what you want to read, saying what you want to write. If you are actually using this in an application context, obviously this is just kind of some sample code to give you an idea of the functions you would use. You would actually want to have something sort of have a long-running connection. You probably would want to store a reference to the GATT object, so you could say, write a characteristic, read a characteristic, kick that off, but then your response is always going to come through this callback. You can hand the GATT object around, but anytime you kick off a job, your answer is always going to come back through this callback. Yeah?
Say like the battery service battery life is so low that it finally just dies out. Do you have an error trap because it's async? Do you have a callback that says I'm not hearing it, so I think this is falling out?
Yeah, so the way that would happen is you would get a call to on-connection state change. So when your phone decided like, hey, I don't know where this guy went, but I'm not seeing him anymore, you would get a call to on-connection state changed. You would have a status of, so status would be connected, new state would be disconnected, and then you would just listen for that, and that would be your signal that whether it went out of range or the battery died for whatever reason. So that's sort of your error trap there. I know this is a lot on one slide. I tried to go through it in a logical order, but anything that's still a little unclear? Anybody want any questions about how you would do anything that's not covered on this slide? All right. So last slide is just a sort of high-level review, just putting all the pieces together. So step one, get your Bluetooth adapter, get your default adapter, and invoke this, well, not invoke, you just get the Bluetooth LE scanner property off of it. You start your scan, you give it your scan callback. The scan callback is the thing that actually receives the devices that are found. In that on-scan result, the result will have a device. With that device, you connect to GATT. You call that connect to GATT function. You give it your GATT callback. And then the GATT callback is where you do all your manipulations. So just like that last slide, we've got the same methods here. On connection state changed, services discovered, characteristic read, characteristic changed. So this is, I made you guys sit through 45 minutes, but really this is it. This is the magic. So it's, I hope that's helpful. Any questions? Thanks for coming, guys. This was fun. And if you need, if you don't want to build a BLE app yourself, talk to us. We'll do it for you.